Hello, everyone. Let's see, we should have a comment section for people that are coming in. Looks like some people are joining in. A lot of what this interactive webinar is to try to answer your guys' questions live. So there's a comment section. Let's see if I can get that to be good. I'll just demo this comment section. Hello. Yeah, and thanks, Kendall. I'll just ask you, Kendall, is my voice coming through all right? All right, good. I appreciate it. So I have a bunch of models already built. The topic and the title of the webinar was, hey, there's this new really cool HECRAS 2025. So I'm happy to do demos of that. There was a comment that came out on how do we do modeling with green infrastructure. I have some models built for that as well. What are the data sources? Happy to demo that. If I don't see, I guess, a number of specific questions that I can answer, then I'll just demo what some of the models that I've built and actually just try to build one. So until I see questions coming in, I'll be monitoring the chat. I guess I see Jonathan's question. Is there audio? I think my voice is coming through. There is about a 10-second delay from what you guys see on the live stream versus what I'm actually doing. So let me just check in with Kendall real quick. Okay, looks like it is good, Jonathan. Kendall's telling me that it's good, but that being said, I'll just jump right into a workflow. So this is Florida. And one of the questions and one of the reasons that I decided to start testing out this tool is there's been a lot of storms hitting Florida recently. Hurricane Helene, Hurricane Milton, and then 2 years ago, Hurricane Ian. And I've built models. Maybe I'll actually show you a built model up here in St. Pete's that I made recently before loading up this one. Let's see if I can find that. St. Pete. Okay, cool. This one's loading up. So I built this model and I guess I can kind of use this as a nice, hey, what's going on with this? When you build any 2D model, the backbone of this is going to be the DEM. So we can use the DEM to appreciate what the topography is. I could also show what the data sources are, because you don't just load up the program and then it doesn't just give you a full high resolution DEM of everywhere. So I'll show you the two data sources I typically use. I might actually have this one loaded up. I'll put this in the chat too. I'll put the links I'm using in the chat. So here is USGS DEM, sort of a nice immediate go-to. So you can, when you go to this website, maybe I'll just load it fresh so you can see what it looks like. So you get this landing page, and then if I want to go find somewhere in Florida, like for St. Pete's, for example, I can go here, and I'm interested in a DEM. It gives me this nice preview too, so I can say, hey, where does a DEM exist? And 1 meter is really nice resolution. They'll tell you lower resolutions in arc seconds, but at the higher resolution, it's always really nice. So here's the St. Pete's area, and I can define an area of interest. Hold down the control button, and I'll say, hey, I'm interested in this area. And then it'll say, okay, what are the DEMs within the area of interest? And it'll load up and it'll tell me what's available at what resolution. So 1 meter is kind of what I'm going for. Looks like it had a timeout issue. Maybe I'll zoom in a little bit more, change it. Let's make it a little smaller area, maybe it'll work better. Okay, there it goes. So it's showing me that within this rectangle that I drew, there's actually 4 DEMs that touch that. So if I highlight over, it'll show me in the red what that actually is. So I'd actually have to download all 4 of these if I wanted to get within that area of interest. So a lot of times I'll just download all of them. The thing about these files, though, is they'll always give them to you in metric. So it's something you have to be aware of or convert them with a GIS tool. Like I use QGIS a lot. The other really nice tool that I use, well, let's see this NOAA one, Data Access Viewer. This tool is awesome. So I get my landing page. I can get land cover from here if I'm interested in impervious surfaces, really useful. Or I can get elevation. This tool focuses more on coastal regions. The USGS tool will give you more of an area. But if I want to go to the same area, you can actually see I'm expanding out more because in this case, the bathymetry data is available. So if I wanted to get this area, then I can see I can get the bathymetry. So this would be actually able to see the topography underneath the water. This is pretty amazing that this is so easily available. Or if I just wanted to get a DEM of the area, it's pretty nice. As I highlight over it, it'll show me what the DEM region's going to be. A lot of the times, the bathymetry data can actually be less useful than just the topography data. So if I wanted to just get, I don't know, DEM for the area, I forget exactly, like this one, I think this might have been, or this one's 2007. So things will change over time. And I'll just use this as an example. They have a little cart feature. There's a question from Jonathan. Is HECRAS 2025 entirely 2D? Yes. It does not have 1D features at the moment. I think they're expecting it to be available in a year. But I have this kind of checkout. It looks like I'm about to buy it. And one of the nice things about this tool, though, is it lets you choose what projection system you want it to be in. So you don't necessarily have to do the post-processing as much. And yeah, you can define what you want to use. So it'll default to the one that's probably the one you want to use. And then if I hit next, I put in my email address, and then it will eventually email me the file that I want to use. So in this case, I think I probably grabbed this one from USGS, it looks like. In this tool, when I load in all these terrain files, I don't have to combine them all into one DEM. I can just put them on piecemeal and it'll load up each part of it individually. And I was really putting this to a test because I've done a lot of surge modeling and other tools. But the next thing that you do is you have to define what your conceptual mesh is. So what that means, if I hover over this, you can kind of see my polygon that I drew. Basically, I use this little editing tool, and you just draw a polygon. This is modeling live, so I'll probably demo this in something more live to show you it work, but we can start with the actually completed model. So you just draw a polygon, and then you can click this Generate Mesh button. Let's see if this turns on. And it will generate a mesh for you. So I think I made this one pretty high resolution. You can see what my grid is. I can make multiple different types of polygons if I want to have different mesh types for different areas, like a river, for example. But a lot of what I like to investigate is how much can I get out of, I mean, in this case, a hurricane was about to hit. So I'm like, hey, can I build this model within a 2-hour period and try to get some insights into what's about to happen, if it's a 6-foot surge or a 8-foot surge, and what are we looking at in terms of areas of impact. So the next thing I have to do after generating this mesh is define a boundary condition. So this is just a line. In this case, I made 3 boundary conditions. I guess I have 3. I probably only needed 2, but along the perimeter, you can see maybe there's a blue line. Hopefully that comes up pretty clear. There's a blue line that comes up over there, and I probably have another one, a blue line over here. So I set that to a normal outfall condition. What that basically allows the model to do, if water's moving across the mesh, if I don't have a boundary condition here, water's going to run up to it like a wall. So I need to be able to tell water hitting here what to do. And in this case, I'm telling it to just run off at a normal outfall condition, meaning just assume that it can keep going, but I don't have to mesh it out. That'll just be my end of the model where water can keep going and it won't be a wall. The more interesting boundary condition is the one that I have along the coast. So this one I have set to a stage, an elevation. So I have this ramping up as a time series going from 0-foot sea level up to 6-foot surge, and then going back down to 0 over the course of 12 hours. I based that off of previous analyses I did during Hurricane Ian down in Fort Myers Beach, like down here, like Sanibel Island and all these places that got a ton of damage. The ramp up on that was on the order of like 15-foot surge down here, but I saw that be a ramp up of 6 hours to peak, 6 hours down. So I'm like, hey, okay, let's just use that to replicate what's going to happen here. And then once I have these components, I'm able to go look at some results. So let's see if I have results loaded. So yeah, I hit run and then it generates this plan for me. I can have multiple geometries, multiple boundary conditions. When I make my plan, I define, okay, which geometry do I use? Which boundary condition do I use? Sort of, I guess you could call it scenario management. Let me turn off these lines to make it a little bit easier to see. And I'll turn on my depth. And I get this slider bar. One of the cool things is when I hit run, I'm able to view results. I don't have to wait for the entire simulation to finish. Let's see how this looks. Okay, there we go. So let me turn this off. Let me turn that off. I'll turn off my terrain. Oh, there is a linear component. So I need to define Manning's roughnesses to everything. So I'll turn this one on. In this case, I just set a constant Manning's roughness value. There are really nice tools in here, though, where when I'm defining my Manning's roughness, it'll actually ping a land use land use source online, and it will automatically populate the areas for you with Manning's roughnesses. In future models, once I figured out that that tool was there, I started using it. But let's just look at results from a pretty rough model. Let me go back to my depth, kind of move that up, and we can, over time, we can see the surge coming in. See how far up it goes. and move it around. And one of the things that I like to do is adjust the colors. It's important to keep in mind that this is an alpha release, so there's a lot of updates that are going on. But let me just change this. Maybe I'll set the ramp. So right now it's set to the pink is going to be 15 feet, but to make it a little bit more exaggerated, I can say, hey, I want to set it to be max. So I'm going to say, hey, if we're at 2 feet, maybe I'll make it a little higher so it's not too sensitive. Let's make it more like a 3 foot. So anything pink is going to be above 3.3 feet. So if we go zoom in on some of the areas here, as we ramp up this 6-foot surge, we can see the surge coming in. And then maybe about 3 feet into the simulation, you can actually see this is probably a dune here, I would imagine, helping to break the surge coming up. And then we could see some of these blue areas are measuring, I don't know, maybe like 4 inches at this point. And then along the street, we're getting about a foot of water. And so at this point, this would be the 3-foot surge. But as we ramp up to the 6-foot part of it, it starts to get a lot more dire. Maybe I'll change the scale again. Okay, so I'm back to about a 6 is the pink. Then we can start seeing that these houses around here are getting now in the order of 2 feet, and along the road I'm up to 3 foot of inundation. And we can actually watch the effect of it hitting these higher elevations on the barrier islands before it bleeds in to the inner bay. And if you guys watch my videos online, a lot of the times I try to figure out, is there any spot check? Is there any news story of what's going on here? So I found a news story with this tiki bar right here, and they had a high water elevation mark. So I try to use that as a form of validation. What sort of elevation am I seeing here? I'm saying that they got about 3.5 feet of water. And then they said, oh, we saw elevation up to 4 blocks up. So I'm like, okay, 4 blocks, 1, 2, 3, 4. So in this case, I'm saying that there is still major inundation up there. And then we can look at these sort of, what does the extent look like? So this is less, this is in the small, even sub-inch mark now up here. But, you know, really useful tool to be able to analyze inundation really quickly along coastal regions. And one of the things I was thinking could be really cool is if, especially as trying to do this really quickly, if the storm's coming in and you don't know exactly where the direction of the surge is going to come from, because in this case, I evenly put a ramp up 6-foot surge across the whole coast. The angle matters. So where is it going to come in? Is it going to come in perpendicular, east-west? Is it going to come in on a northeast angle? And I could adjust those boundary conditions as more information is coming in about the storm in order to figure which type of surge event are we looking at. So that's that model. I was planning on actually trying to build one of these because I built it for up here, and then where I was hanging out just yesterday down in Port Charlotte area, they had high water marks from Milton and Helene up to like 5.5 foot measured at my buddy's house right here, and that was the highest they've ever seen. So he had water just, he was in his garage. It was about an inch or two below entering into his first floor. So I wanted to try to build a model and then take into account this big mangrove that's here. And then actually see, could I replicate the surge event that he's seen from both Helene and Milton? I'll show you another tool that I use when I actually try to figure out, like, okay, what, instead of just, you know, putting in 6 feet, is there anything that I could use to justify that? Let's see if I can find a tool like that. Flood event viewer. So this tool is really awesome. I'm on a really nice tool from USGS where during major events, they actually will log in and they'll say, okay, we're going to categorize everything here as Ian. And then they go survey what the damages were. So for example, Fort Myers Beach, you can say they actually go around and they measure high water marks. So this one they're saying they had 12.5 foot. So if I go here, I can actually look and see what it looks like. And they actually have photos and they'll go out and they'll look at these high water marks. Say, okay, that's clearly a high water mark. Looks like we did get a question. How would the direction of the wave be included in the boundary condition? So for example, with Charlotte Harbor, am I going to make the boundary condition be the surge starts here? That way the water, when it pushes in, we're going to get the dynamics of it having to move through this channel, have to take this turn, and then move up. Or in the case of Ian, when Ian was moving up, original path was going to move up into Sarasota, which is where I hang out. But it just stopped here for about 5 minutes and then decided to take this really odd turn, and it moved into Charlotte Harbor and then followed up. So then in that case, the direction of surge actually is now pushing in a lot more directly. So it doesn't have quite as much of this buffer. There's a whole wind dynamic that's going on here that this model is not taking into account. But I can create a proxy for it by creating a boundary condition. So if I know that it's going to move directly through here, I'm getting a lot more of a direct push this way. So maybe if I'm most interested in this region, I'll put the boundary condition more direct. So it's now shooting it this way, as opposed to if I want it to be shooting in water from this direction, then have to play around with the topography. I'll put the boundary here on a perpendicular line. Let's see if I got any other questions. I hope that answered it. Oh yeah, so I'll go back to this high water tool. So they're going around, they're taking photos. Let's see if I can find another one. Yeah, this picture I thought was pretty interesting. Actually pointing a high water mark on the door frame. So really useful to when you're looking in the past about what happened, what exactly happened. Some of these are listed as photos, and they actually have a full gauge. There's a pier right here. I guess it's not showing up so well. But yeah, they actually have a meter pressure transducer. So you can look at how long or what the pressure transducer was reading throughout the duration of the storm. And they give an unfiltered, and then I think they do some sort of mean average to come up with, let's use this as what the official level was. So this could be a wave, like an instantaneous wave that was read, but overall this is what the water elevation was. I think they have some photos of yeah, we can actually look at what this looks like. It's kind of interesting, just ratchet strap a pressure transducer on the pier. One of the other questions I get, actually had yesterday, especially when we're looking at comparing, this new HECRAS tool to some other ones. Let me go see if we can find an interesting one. Let's do Exton. This is my hometown. I didn't make a model for this yet. I mean, this could be something I could kind of model out live. In fact, maybe we will. Let's just make a model. We can kind of appreciate what's going on. Let's see. Why do you choose the equation set diffusive wave? I don't think you have much control over what solver you use in HECRAS 2025. When I look at their roadmap, it says maybe it's the end of their roadmap. They'll give you control over what solver that you can use. When I do modeling in SWM, I have a lot more control as to what solver that I'll use. I'm not sure they call it an explicit solver, and I think that simplifies the equations a bit, but it makes it run much faster, so it's a pretty nice compromise. Let's see if I can actually look at this. It's from satellite. So more of a suburban area outside of Philly. Philadelphia's over here. So maybe I want to get a idea what's going on with this dynamic. So let's just try to do it. So ideally, I would take the time and I would draw a perimeter around the whole DEM to get a nice complete picture of the whole area. But just for the sake of demonstration, I'll just draw a really quick one. Now I need a boundary condition, or I'll generate the mesh. I can set what my cell size wants to be. So in this case, I'm going to use 100, and I'm going to use one type of shape. I see a question about HECRAS being used for production. Right now on their FAQ, they say that this is not to be used for anything official. What you can use it by the recommendations of the HECRAS folks is for generating a mesh, which I just did. Then this mesh can be export to HECRAS 6.6. You can create the mesh. I understand mesh creation in HECRAS 6.6 is leaves a lot to be desired. So the mesh tool in here is much stronger, but you can create your meshes in here and then export them into 6.6. So that's a pretty big quality of life improvement. But at the time, this is the only thing that they recommend using this tool for. It's an alpha release version of the software, not even beta yet. And they're expecting it to be, I believe, next fall is the official release. All right, so I have my nice mesh there, and now I'm going to add a really rough boundary condition. They have this nice thing where if you hold shift, you can move around. All right, so there's that. And then I actually have to set what's going on with this guy. This is right now, it's just a line. So it's going to give me a question mark. So let's solve this question mark. I want to make it a normal depth. And I'll just give it some Manning's roughness so it can calculate a boundary. I just want to have it so that water can't just treat this as a bathtub. This is not a bathtub. Let's see if I can test out this classifications layer. Maybe I already loaded it. Okay, so this is what I was saying before. I'm able to, this button up here, I can import in this data layer and it'll give me some classification of land use. Did I miss a question? I think I'm okay. And then I can use that to generate my end values. Let's see if I actually did that. No, I didn't. So let's use this to create end value layer from this list. Call it end values 2, a perfect name. So there we go. Now if I go to my plan, let's see if I can select a geometry. We'll use my geometry. And is there anything else? Yes, there is another thing. I don't have any boundary condition here like I had in my other models where I was able to show like a surge. So in this case, I want to test out this rain on grid tool that they have. So I'm going to turn on rain and I'll just give it something like a lot so we can see. I'll give it 5 inches an hour. It's showing all as one red color. It's interesting. It looks like in the future they'll have nice tools where you can use a raster of rainfall, so it'll be different rainfall throughout the whole catchment. And it looks like they'll have it tied to meteorological stations, which would be cool. That might exist now. I just haven't tried it out enough. I see another question. Can you confirm mesh development much nicer? Yes, Drew, I'll just finish up this model, then I'll pull up one I did for Asheville. So let's just give this a run. Right now I'm live streaming and I am running a bunch of programs. So hopefully this doesn't slow down everything. Gives me this cool little running guy. So the first thing it does is it samples the mesh. And once it does that, I'll actually be able to view some results. So let's see if I can view some of it. Yes, okay, so it's pretty cool. Even though it's not done the run, I can still view. So this is turn off some of these layers so we can look at it a little bit nicer. So there's my depth. I kind of want to make it look a little bit more kind of extreme. Oh, that's a terrible color scheme. Is that even going to work? Let's try that again. There we go. There's a better ramp. Knock it down a little bit. Change the ramp. So I wish I could manually toggle these, but I can't. But we're able to get an appreciation really quickly for what would happen if we dumped a bunch of water from rainfall on this mesh. What is it not doing? It's not taking into account anything 1D. So for example, where's it going to fail? There's a culvert right here. If I look at my terrain, that terrain, it sees that there's a low point here, but then it goes up to the road level. So for this model to be more accurate, I need to have a 1D structure be able to go through this road. Otherwise, I'm going to have to go in my raster and create the channel directly in the raster. You can probably see other places might be more dramatic over here. So right now this is a high point. Water moving down here, it's going to hit this, it's going to be a wall. So I would need to have a 1D structure in here, which I don't have the ability to do. But I am able to get a pretty good understanding of what's generally going on in this little area. And it's not that hard to do this, draw the whole perimeter over everything. It just takes a little bit more time to go along throughout the polygon and figure that out. But all right, the question about rivers. So I made an Asheville one. So in this case, this one has two different types of polygons, two different types of meshes. So I can see that I built this. Go in here, maybe kind of click this. I have this polygon for the river. This is the French Broad. And I did take the time. I mean, I could have made it a lot cleaner. Could have expanded the watershed a bit, but I just wanted to give a more even flow mesh for the major channel of the French Broad. And kind of appreciate that. And it does a really good job kind of fixing everything and meshing it together. There was another stream up here. This is the Biltmore Village. And if I was spending more time on a more professional model, I would have created a better mesh for this channel. This is sort of another kind of quick and dirty demonstration for my own knowledge to get used to this tool. But I did take the time for the more major French Broad to get that going. Let's see if I have results loaded in this one. Yeah, so let's see if I can change the ramp. Turn off some of these layers. Drew, I hope that answers your question. So one of the major things that I get asked about this, especially if I went back to my Exton model, is how do we deal with 1D structures? HECRAS 6.6 has the ability now to import in SWM models if you want to do something like an actual drainage network, an engineered drainage network, stormwater pipes, culverts, etc. So here is an example. Let's see if this GIS engine loads up real nice. There's a lot of data in this one. See if I can turn on a background layer. I see another question coming in. The bottom line is that we use HECRAS 25 just for the creation of mesh and return to HECRAS. At the moment, that is where everything is at by the official narrative. You're not able to use 1D structures. You're going to, if you're going to be doing any sort of river model, you're going to need a culvert. You'd have to bake that into the raster to pull that off. Right now, the workflow in HECRAS 6.6, the two advancements in it are you can import in your mesh from the new tool. It's a major improvement. And you can import in SWM models, the 1D elements and the 1D assets made in SWM. You can import those in to HECRAS 6.6. I believe you can build them yourself in 6.6. I haven't tried it out, and I can't really comment too much about the workflow there. But if I was if I was trying to build a HECRAS model with 1D elements, I would want to build them all in SWM. And this is the particular tool that I use the most is PC SWM. So I'm able to pull in city GIS elements, and then I'm able to clean them up. A lot of municipal GIS data is really dirty. You'll be missing invert elevations, you'll be missing rim elevations, you'll be missing pipe diameters. So being able to take that city data and then clean it up is going to be really, really important. Let's see if I got a few questions. I'll just finish that point real quick before reviewing questions again. So like, for example, if I want to QA/QC a lot of this data, and I've already done a lot of the QA/QC on this model, but if I'm curious, like this pipe run, for example, see if I can go check it out. Let's take a look, or maybe I'll go do it here. Let's see if I go check out this profile. So if I want to go check out this profile, like a lot of the times when I do just a raw import of this GIS, it'll look something like this, where I'll just have this profile with a 0 invert elevation. It might not even have rim elevation. It'll break the model. I've just created a huge pit in here. So let me just kind of bump this up to reality real quick. So one of the things I'm going to want to do is I'm going to want to figure out, oh, okay, I can use the DEM. I have really nice PC SWM tools to say, okay, sample the DEM. Tell me what the rim elevation is of each one of those points relative to that. And then if this is just a 0 point, I'm going to have to figure out some reasonable spot to put this pipe. So as a bit of a close proxy, just to have something to work with, I'll say, okay, take my rim elevation, subtract 5 feet or something like that. Now at least I have an invert elevation that makes somewhat of sense. But I'll go back to the profile. But like in this as an example, I have a negative slope pipe right here. That's probably not the way that was built. Maybe it is, but maybe I'll go ahead and I'll say, hey, I want to like move this thing down. Actually, that's giving me way too much depth. Let me try that again. So if I want to move that, oh, why do I keep making that mistake? Selecting tool. So if I want to move that up, I'll say, nah, I really want this to be like here. And this one, I really want to be like here. And then this one's a negative slope. So maybe I want this one like here. And now I'm able to use, even though I was missing data in the GIS file, I'm still able to create some sort of reasonableness in the model and not break it. Okay, let me see if some questions. Can HECRAS create water surface profiles inside long culverts? Yes. So they're actually right now you can have a profile tool and you can cut profile lines. Bob Dickinson, thanks for coming, Bob. Will the data structure be the same as SWM 5? Same node and link data, but different SAMPANOP solutions. I haven't tried out the tool myself. It is currently there. If you go to HECRAS 6.6, there'll be a button that says import SWM 5. Once it brings it in, I believe it's converting it to a different type of HECRAS 6.6 solver. I don't think it's using SWM solver directly. It's using a different solver. But I believe it's set up to be in a way that once you build your model in SWM, it should be able to pull it in to the HECRAS 6.6 solver ecosystem. I would be really interested to hear feedback from folks that have tried out that new tool. One of the workflows I imagine is going to be really useful is you build the 1D elements in SWM. And it would be really nice to have just a purely 1D model. You get that to run real nice. And then if you want to throw in the HECRAS 2D workflow to that, then you can actually compare and have those two models be separate but working together. Right now in PC Swim, I do have the ability to use a 2D mesh directly, which is actually really quite nice because then I can have what's called an integrated 1D, 2D model. So I can have my 2D mesh. Let me turn that on. It looks like Bob is telling us that it is, in fact, a different solver. So in this case, I have the way that PC Swim does its 2D meshing is it actually is using Swim 5 elements and it's sampling the DEM and it's creating these Swim conduits in order to come up with a mesh network, finite element network, in order to sample that DEM. So I can create a fully 2D network fairly quickly in PC Swim, just like I would do in HECRAS. Where the advantage is of doing your 2D meshing in here is really when you're dealing with these 1D elements. Because right now, I'm able to take advantage of all of these tools and all of my import GIS from my municipal folks in order to help build out what's going on with all these drainage networks. Like if maybe I can go find my spot I know pretty well in here. Turn that out, make things load a little nicer. This is actually a pretty nice little comparison here. So try to turn off some of these conduits. Turn on a lot of stuff. So this looks, turn off these conduits, make it look a little nicer. This looks really similar to the really quick and dirty model that we built in HECRAS. But because I have these conduits here to deal with these culverts, I'm able to get a lot more realistic. It's not going to back up as much like it did without having that culvert in there. So now that I have the culvert, it's a lot more easier for it to drain down and find its way more accurately as to what's actually going on in reality. But especially when we get to these downtown areas, if I'm not taking into account the things like the catch basins on the street, so this is actually a spot that floods during major storms in the town, this intersection. But especially if I run out the model in time, we'll see that these catch basins are actually really helping to drain down a lot of these pockets of flow or of inundation that wouldn't be able to be taken into account in a purely 2D model. I need to have these 1D elements in order to see what's going on. And then a lot of ways we're using these models in order to be design tools anyway. So I could use a fully 2D model in order to figure out where are the pockets of ponding that I'm going to have in order to help me decide where am I going to need to put an inlet. Put the inlet in the low area that it doesn't have any way of draining. So like in this parking lot, for example, there may be a drain here that wasn't in the municipal GIS database, but if I could go out and I could walk in this parking lot, and I have a lot of certainty that if there's a low point here, that this is going to be flooding. And if I wanted to help improve flooding in this is the mall parking lot. If I wanted to help improve flooding over here, I could add an inlet, and then I could figure out what the size of that inlet needed to be, and then I could help really inform the design of helping the city. Let's see. Can you bring the mesh from HECRAS to PC Swim? At the moment, no. The 2D meshing of HECRAS is fundamentally different than the 2D meshing of PC Swim. That being said, there's a lot of tools that I use in PC Swim. Let's see if I have them loaded up. Just hide everything. Let's see if I have. See if that's the one. No, not that one. Let's try this one. I don't think I know exactly where that one is. Maybe this one will get the point across. I'm going to choose my road one. That'll get the point across. Okay, here we go. So I have a road polygon. This one came from the municipality, but if I don't have this, it's pretty easy to get street center lines. And I can use a buffer on that center line and say, hey, buffer out like 15 feet in either direction. So I have a polygon for the roads. And then I can use that when I have my mesh generation, instead of me like I did in my workflow with HECRAS where I have to draw out everything, I can actually use my GIS polygons and say, hey, give my road a different type of polygon, give my road a different type of Manning's roughness so that water can flow more like a directional flow path. Let's see if I did that for when I built this model. No, I did not, but I'll pull up a model where I can show you that. And while that's loading, let's load up one of these other ones. Let's load up this one. In the meantime, I'll look at some questions. Would you not call what you can do in HECRAS 6.6 an integrated 1D, 2D model? Jonathan, yes, I would call that an integrated 1D, 2D model. Okay, let's see. Does 2D PC Swim model backwater from CBS, some catch basins and delineate back flooded areas? Will that be governed by the same catch basin hydraulics? Okay, let me tackle that one. This is going to close this one. Generally, yes. So you can model inlets a number of different ways in Swim. The most recent release of Swim has actually an inlet module where you can use things like highway rating curves, and then it's a two-way street. So depending on how you model it in 2D, you can either send the water from the 2D mesh, like a rain on grid, and send it into the catch basin, or you could use subcatchments and send it directly to the mesh, or send it directly to the 1D elements, and then if that floods, it'll back flood out onto the 2D mesh. Depending on how you want to do it, but generally, yes, you have a two-way street with these 1D, 2D connections. Here's one from David. Have you investigated the simulation results between PCSwim and RAS? Are they comparable? Um, yes. So I've ran quick models when I was exploring because HECRAS 2025 is pretty new, and I was never super into doing Hex 6 modeling because to me the user interface is really it's really a challenge, and the ability to make a model and build it really quickly and get it to be nice and presentable, it takes a lot of time. But the HECRAS 2025 tool, you can build stuff really fast and it's really nice. And have I compared my models in Swim Surge to HECRAS 2025? Yes, and they're really similar results. Um, Actually, that would be a fun thing to show. Maybe once this model loads up, I can show some of the really cool swim models that I built. We try to load that up because I think our scheduled time was on the order of only 10 more minutes from now. Okay, so this was an example where I have a different type of mesh. This is a pretty quick and dirty model. I have a different type of mesh for my road, and maybe I can pull up my bounding condition. Bounding layer, maybe this will be a little bit more obvious. Turn that on, turn off my 2D cells. If I go on this road, like I could have made this, I should have made this high resolution, but I have a different, maybe that's obvious, maybe it's not, but I took my polygon from my road and I gave it a different type of condition so that when I create my mesh, it knows without me having to draw every polygon to give my roads a higher resolution mesh. I want it to have a lower Manning's roughness when it builds my conduits. And then I want to give my regular surface a lower resolution. I want it to be a little bit more um, less higher resolution because otherwise the model run could take a while. And there's weaknesses here. For example, I should have included a higher resolution polygon along this line in order to tell my model, hey, when you're building it, I want to have a higher resolution mesh along this really important hydraulic of this creek, this little stream. It's kind of building in there. But these are things that are really nice when you're building your mesh, is to say, I want to have a polygon here, and I want that polygon to automatically build for me my mesh. I don't want to have to manually go around to every single element and define the mesh generation. I want to use GIS files to build that for me. So this is a pretty obvious weakness to me. This was a model I built in just a few hours, so it has some issues, but like scrutinizing this, I would use a new polygon here to define that I want to have a higher resolution mesh along this area. There was the question about, I can demo that here, about inflows and outflows from catch basins. So in this case, I'm using an orifice connection here, pretty wide orifice connection here. I can change this to be whatever type of inflow outflow that I want, whatever rating curve that I want. But to answer the question, it is a two-way street. Water can come in and it can come out. Let's see if I'm getting all the questions. Okay, let me try to show you some really cool stuff. This is really nice tool from CHI. Let me load it up. Hopefully the internet connection can handle with everything I'm trying to do. Let's load up. Let's load up my surge model. And why this is loading, there's a question of how do you apply rainfall directly to the mesh. So there's two ways. A new version of Swim or PC Swim is about to come out, and that version will has a tool. In fact, I have it here, so you get the sneak peek. I can do rain on grid. It gives me a rain on grid toolkit button. And what it basically does is it removes subcatchments. You don't need them anymore when you do rain on grid. And it will create an inflow time series for you directly into the 2D junction. It has some other interesting tools. Like if you have a buildings layer, you can actually select where the downspout is. So if you want to send it to a particular side of the roof, it'll send it there, or it will evenly send flow to the surrounding 2D meshes. The way that I would do it before, and I'm not sure exactly how I've decided which is my preference because it's so new, I haven't tried them out enough, is you can use your 2D cells layer, and you can use these 2D cells, and because this is already a really nice polygon layer, you can import subcatchments. You say, I want to use this 2D cell layer to create subcatchments for me. And then all of these 2D cells will become little subcatchments. And then it'll send its subcatchment flow directly to its nearest junction, which most of the time will be right in the middle of that subcatchment. There's a lot of interesting questions about how do I deal with the flow length? Am I double counting flow length if I have the flow length of the subcatchment and then I have the overland flow of the 2D network? How am I dealing with the infiltration that's going on in the subcatchment and then also the infiltration that's going on across the 2D mesh? I think that there's a warranting question for a little bit of research to kind of test out which modeling approach is going to work better. Let's see. Oh yeah, I was loading up this nice 3D model. So this tool is really cool. Not only does it give you really nice 3D visualization, you're effectively taking your 2D swim model, or any swim model for that matter, in the package file of PC Swim, which is basically just a zip file. And then they're loading it up into a cloud simulation. And it's able to give you really nice visualization tools and kind of take I mean, especially in the 2D realm and especially in the nature of stormwater, a lot of what we're trying to do is we're trying to tell a story. And when the model just sits in your ecosystem and your desktop, you need to be able to have a way of conveying those results and breaking it from the silo of a desktop. So it's sort of like an answer to that. This is pretty cool. I have a YouTube video and see if I can turn off that audio. So the story behind this was those 13-foot surges. The people of this Fort Myers Beach are completely devastated by this. This is a catastrophic event. And when I was down here in Ian, I wanted to see if there was a way to try to bring all the work I do in modeling to try to create some sort of, like, how could we address this? How can we make this real? How can we recreate this in a digital twin type of environment so we can start looking at these things, start talking about adding resiliency, talk about who's at the highest risk, just really trying to get my own head wrapped around this and then be able to try to tell this story. So I guess moving ahead a bit, I can sort of just, this is a whole presentation in itself, but maybe I can skip past the kind of the PowerPointy stuff. Show the model build. Get to the kind of like the 3D elements. I think it might be about here. You can actually now run the model. So check my internet connection. This uses quite a bit of CPU. See if this will do a nice run for me. I'll check the questions. David asks, would you recommend using an adaptive mesh to define rivers and roads? Not necessarily. For a river, I would recommend using a directional mesh, or let me just double check what they call them. So there's a rectangular mesh that you can use for a road that's going to be better for the road, and then there is a directional mesh that's going to be better for a river. So in order to run a directional mesh, in order to generate a directional mesh, you're going to need a center line. So that's one of the things that you might not always have. There's ways in GIS in which you can pretty rapidly make them. But once you have that center line, because you don't just want to use a rectangle, you want to have it actually be able to do the bends of what the flow path is. So you don't want to use an adaptive mesh. You want to use a directional mesh ideally for a river. And for a road, you want to use a rectangular. Let's see if this will actually do a little run for me. Looks like it's not so happy. Maybe I'll just move it along so we can see what happens. But I get the full time series here where I can move around. Looks like it's taking a little snag at the first time step. But generally I can move this ahead. I can watch the surge coming up, and I can look at the risk in real time as to what's going on with the surge. And at any point I can kind of move around and take a look at what's going on in this 3D environment. Okay, let's see if I have this questions. Okay. That does bring us to the hour. I notice we have quite a few people hanging out here still, so I really appreciate that. I will take a pause there. Oh, there was a question I didn't ask about building GIS. Somebody reached out to me on the side to ask about, I'm sorry, not GIS, GSI, Green Stormwater Infrastructure. So maybe I could show that real quick. So here's a model to analyze a green roof. And let's say, how do I want to do this? Well, in SWMM, we have these LID controls, and you can build up a green roof, and you have a surface layer, you have a soil layer. That'll be like the porosity of the soil, the field capacity, how fast it infiltrates, and then there's a drainage mat. This is the lowest layer that helps it leave the roof. Mohammed, I see your question. What is the name of that tool? Is it in PC Swim? It will be in PC Swim in a week or maybe 2 weeks, and it is called Rain on Grid. I'll show it to you one more time. So you go Tools, 2D Modeling, Rain on Grid. That'll be, if you update your PC Swim in a week or two, it'll be there. But as I said before, as you can do right now, is you can, once you have generated your 2D cells, you could say, hey, I want to do an import, and I want to create a subcatchments layer, and I want to base it based upon my 2D cells. And then this will create all the subcatchments for you, and all those subcatchments will be identical to the 2D cells, so that'll effectively be rain on grid. There's another one. How sensitive is the rain on grid peak flow and runoff values to the mesh resolution? How do we select most appropriate mesh size for rain on grid for practical applications in urban areas? Well, if you use the subcatchment area, this would represent the area in which rain was falling, as opposed to if you use this new tool that again is coming out a week, it's going to be the resolution of this. How do you decide what resolution to use for rain on grid? I think the question about resolution is less about for rain on grid and more about flow path dynamics. So if you have too low of a resolution, like I have in this model for my creek system, I'm going to be missing the dynamics that are going on in that creek. That's too low of a resolution. The resolution needs to be more set towards how interesting are the dynamics hydraulically of what you're trying to model. So in the case of a road, for example, I know that a lot of the times roads have curbs, and I want water to have a nice ability to flow down a road because that's a lot more realistic. So I want to have a higher resolution for a road, and I definitely want to have a higher resolution for a creek or a river. And I want to, and then I can get away with having a lower resolution for the surface, for the general topography of the more overland flow paths. Where was I? Yeah, green infrastructure could answer that question. So one of the questions is, where do I get this information? Excuse me. There's a lot of places you can get this information, and I'll show you real quick what's sort of like the standard go-to. So the SWMM manual is super nice for GSI. Go on here, stormwater management model, and I can go find, let's see, it's tucked in here. SWMM reference manual volume 3 water quality, and then they have in parentheses includes the LID module. So if I go here, and then it brings up this kind of old school PDF viewer, but if you click this PDF button, you can actually download it. And this is 161 pages. So I can scroll down. I could do a Control F. All right, just find it. I've looked it up enough. So here we go. We start talking about what's actually going on. So bioretention cells, the first option, and it's kind of the prototypical one, but we have a surface layer, a soil layer, and in this case, because it's bioretention, a storage layer. In green roofs, this is replaced with a drainage layer, and infiltration in this case doesn't actually happen, so that's nothing. They actually tell you all the different terms, which are useful to understand. You know, if you're taking the trouble to get into this manual, it is a good opportunity to actually look at how is SWMM actually managing this. So there's a change in depth over time for each one of these layers. The soil layer is actually a moisture. So it's saying that this theta is the soil layer moisture content. So that's actually looking at it a little flipped way. So you get to appreciate some of the SWMM nuances. And then there's an evaporation term, which is really useful, especially for in-depth green infrastructure analysis, particularly green roofs. We can go down and we can find basically a lot of the time someone wants to have the ability to justify a good spot to start. Here and find these tables. They're here somewhere. Here we go. So give you typical ranges for bioretention cells. Typical soil characteristics. Let me go find the green roofs. So green roof parameters, freeboard, surface void fraction, soil layer thickness, soil parameters, what's good porosity, what's a good field capacity, what's a good wilting point, saturated conductivity. So these are the terms that you can use when you fill in your LID control modules. And are they going to be perfect? I mean, if you have actual data to justify the parameters that are in your module, I mean, that's the best. But if you don't and you want to have something justifiable, this is a really good spot to start. There's other really nice tools that you can use too. And I think there's a major update coming out for this soon. But the National Stormwater Calculator is a really, really nice spot to start. So just do this, click this big button. It gives you this really nice term. Well, let's just go find a spot. Maybe go pick New York. So this is actually where I built my green roof model. So I'll say I can use this to create a full model and it'll get a lot of nice insights. But I actually just use this tool to grab the information out of it for building models. So for example, if I want to get the data to you for continuous simulation on green infrastructure, it'll be able to grab, so in this case, LaGuardia. I can grab rainfall data. It's telling me it's going to give that for about 30 years. I can grab 30 years of rainfall data, and I can grab 30 years of temperature data, of climate data, which I'm going to need for ET. So I could run a design storm on here. So if I want to do like a rain gauge, I could say, hey, I want an SCS type 2, or maybe like a 4-inch type 2 design storm. And I could just do a 24-hour design storm to see what happens. But in green infrastructure analysis, and particularly green roof analysis, being able to understand the evapotranspiration patterns of this system are really important. So those two files that I can so easily grab from here, that's ready to go for SWM. That's an importable, I think it's a .dat file ready to go. Makes it really convenient. So if I do climatology, I can say, hey, here's my external file, yeah, .dat, ready to go. I have to define what units it's in this case it's Fahrenheit. And a lot of folks in the academic community really like to use Penman-Monteith. This is using a simplified, simply based on temperature data. So it's a bit of an approximation, but it's still pretty accurate from the research that I've done. And then I can say I want to get my evaporation from that temperature file. I can also put in monthly averages too. There's a lot of really nice databases that they will just give you the per month ET rate to use, which is actually based upon either monitored data or Penman-Monteith equation for a particular type of crop. Sometimes it's like a grass they'll use. And I can decide if I want to evaporate only during dry periods or not, under the assumption that if it's raining, it's not evaporating. But then but then I can run that and I can start looking at this over a large period of time. Let's see if I can turn my rainfall. So we can kind of change these colors a little bit, a little less thick, like medium. Okay. So there's a lot of periods, particularly in the summer, that these smaller rainstorm events are not going to generate any runoff, especially when ET is higher. But then when I get to these kind of larger events, and especially back-to-back storms, you can really start getting an appreciation for the dynamics between antecedent moisture conditions, how big of a rainstorm am I going to be seeing, what are going to be my wettest periods, what can I be expecting during different types of events. Kendall's letting me know it's a bit blurry now. I hope maybe my CPU usage is getting a bit high. Let's take a peek. Start closing down some of these high usage applications. Yeah, that model was taking up 5 gigabytes. Okay. Does PC-SWM have an infiltration layer? Yes. Well, you typically deal with infiltration in SWM at the subcatchment level. So you can define subcatchment infiltration a number of different ways. You could use a land use categorization. Uh, the most refined method that I found to do it is go to web soil survey. So for example, close this out. Actually will give you a very rough land use from here. I forget where it is, soil type. Yeah, they'll give you a really rough infiltration from here. But if you're going to go through the trouble to do a higher resolution infiltration layer, you're probably good to use web soil survey. So you may have seen this tool before. It's actually really quite nice, but say I want to go like somewhere in PA. So let's just say this is your area. You have to use this tool. You zoom into an area, and then you have to define an area of interest. It could be a rectangle or a polygon, but just for the sake of it, we'll just make a quick rectangle. And then you got a bunch of tabs over here, and I always forget which one to use, but I think it's soil map. Is that the right one? Or is the soil data explorer? Let's see. Yes, so soil data explorer, and then I'm interested in, I have another set of tabs, the soil properties and qualities. So I can go in here, and I think it's in soil physical properties. Yeah, so I can get terms for green damp from here, water capacity, and probably what I want is I want to have the saturated hydraulic conductivity KSAT. So that's super important for infiltration, regardless of what method you're using. So I can say, hey, this is what I want. And then you get some other options, which is sort of like a bit, oh, don't want to do that. Oop, zoom back out. Zoomed out too far. So this gives me a lot more resolution for a justifiable infiltration parameter. I have to then actually decide, hey, do I want to get, according to Web Soil Survey, what's going on at the surface layer, or do I want to take it from a top depth to a bottom depth? And I have to define how deep I wanted to do it, or I don't want to give it from an all layers, but just give it from surface depth to see what this looks like. So it will then tell me, and then I can import this into PCSWM, and I can say, hey, do area weighted calculation for each one of my subcatchments. I want to be able to see what the corresponding polygon is compared to Web Soil Survey. So it'll give me these ratings in micrometers per second. I'm going to want to convert that into whatever the units are of my SWM model, but it's in the US inches per hour. So I have to convert all of these into inches per hour. And then once I pull that into PCSWM, I have these nice tools where I can do, let's do background layers, and I can do spatial weighting. So calculate attribute values based on spatial weighting. From here, I would download, like add to shopping cart. I can download this, and then I can have this as a GIS shapefile. So then once I have the GIS shapefile, I could bring it into PCSWM, and I could say my data source is going to be that Web Soil Survey GIS file I just had, and I'm going to send that information to my subcatchment layer, and I want to do area weighting. So I want it to be, if my subcatchment is half occupied by one of those Web Soil Survey polygons and another half from another Web Soil Survey polygon, I want it to 50-50 average the infiltration rate, and it'll come up with it automatically that way. It's actually a really nice tool. It's, if I'm just building a model super quickly, I'll just try to create some reasonable infiltration rate just to test out to see if it's running. But if I start getting into the details, this is absolutely something I recommend including in your workflow when you can start having more realistic and primarily justifiable infiltration rates in your subcatchment layer. Let's see. Looks like Doug had a question about water and wastewater modeling. So yeah, that's a lot of the work that I do is stormwater. SWM does do combined sewers. A lot of its history is in combined sewers. So I can add dry weather flow patterns into here. I can do a fully sanitation model where I have pumps, and I can add dry weather flow patterns, and I can add pump stations, and I can look at the dynamics. I can add I&I in order to see what happens during rain events. A lot of what the combined sewer and sanitary flow models are fully built in SWM. As far as water, PC Swim is actually quite nice, where I can fully open a and build a EPA net model in here too. So if that's something I'm interested in, I could build an EPA net model. Let's see if I have any more questions. How would you go about incorporating snowmelt? So snowmelt is possible to do, although it is not something that I have actually done. But there is this snowpack tool, and if I wanted to educate on me, this is a nice thing. It's kind of fun if you're real nerdy about modeling. Click this little question mark, and it'll take me into the PC Swim snowpack editor. If you don't have access to PC Swim support tools, you can read all about this on the swim manual that I pulled up on the website before. This is likely in the hydrology section if I was going to guess. And a lot of the information that's in here from PC Swim is highly informed from that swim manual. So that swim manual is it's really useful, especially if you want to understand the equations behind it. Let's see. The snowpack editor allows the user to define snow melt parameters and initial conditions for snow that accumulates over 3 different types of areas: the impervious area that is plowable, the remaining impervious area, and the entire pervious area. So it looks like you have some sort of land use that you can have. And then you can define melting coefficients, it looks like. Inches per hour per degree. So it looks like it's based upon a coefficient and air temperature. So you probably need to have a temperature file in here in order to have some sort of rate of melting, and then it would add inches per hour based upon that. And then it looks like there's actually a snow removal function as well. So it looks like it's quite sophisticated if you wanted to get an idea. Let's see. Is GPU utilized during simulating the 2D in PC Swim? I think that generally, I'm not sure if I could configure my computer in a way to fully utilize GPU capabilities in ways that others can. Generally, Swim is highly relying on the CPU. So if you want to run Swim models fast, you want to have a really nice CPU. I run a laptop that has a decently high CPU. Let me see if I can pull up my system specs. So I have a 12th generation i7 14 core processor. And let's see if it tells me my single speed. Oh yeah, there it is. So it's a 2.3. If you're trying to do so, if you want to run swim models fast, you want to have a desktop ideally, and you want that single core speed to be as high as possible. Having like a whole bunch of cores is going to be useful for a lot of other processes, but if you want to run really fast swim models, you want to have a desktop with a high single core speed. And I mean, I would have a desktop for the amount of modeling that I do, but I travel a lot. So having a really nice laptop works just fine for me. But I also have a lot of RAM. I have 64 gigs of RAM, and this makes me be able to do. I mean, right now I'm live streaming. I'm doing HECRAS modeling. I'm doing PC Swim, doing QGIS, and I think it's been running pretty fine. So if you guys have other questions, keep them coming. Happy to keep answering for everyone. Yeah, it's really nice to have Bob here to give a lot more context to what's going on. All right. Like I said, I do have a delay from what you guys are seeing compared to the chat. The chat is what I get to see live, so I just put in a question there. Um, I'll hang around for a bit more time. If I don't see any more questions, then I'll probably wrap it up. I try to be available online. I think on LinkedIn, I usually do a pretty good job answering messages or questions. I'm trying to help folks out. There's definitely a lot to know about modeling. There's a lot of nuance to it. There's a lot of what are the data sources available. There's a lot of trying to tell a story. Um, I really like it. I think it's been a really exciting part of my career is to try to use a lot of these tools in order to answer a lot of questions and to try to make it meaningful. Try to use it in design, try to use it in storytelling. So, and I understand what it's like to not know how to do it, and I'm always still learning how to do stuff. So then I always appreciate the community that's available to help with these things. And that might be a good note to wrap things up on. I really appreciate it. It looks like we had a pretty good turnout. This is something else that you guys would like to see, then if you could maybe add some comments or give some feedback on any things in the future you would like to see. I mean, this is something we put on to keep everybody connected. Looks like there's a message. Let's see. I think with that, I'm going to wrap it up. And yeah, like I said, please reach out to me on messaging.